Yes, ma'am.
Thank you so much. Right. Okay. So let's jump right in so that we somehow managed to end up lagging a little bit behind. So, as you guys may recall, last week we ended on discussing, essentially looking at a particular type of problem which involves the conservation of momentum, and that was impact. Let me start the recording. So yes, so we were looking at a particular type of application of the conservation of momentum, and that was looking at problems of impact, right? So first of all, we noted how, okay, in impact it is essentially a problem where there are just internal forces or internal impulses acting, so and no external impulses acting, such that this is a problem in which the conservation of linear momentum holds true, right? So with that information we were armed with one set of sort of one piece of information that we could use to solve it. Like, and then we saw, okay, most of the time when we are solving this impact problem, then we have two unknowns, which is the final velocities of both our particles A and B, if we had two particles colliding like so. So if we need two pieces of information, then we saw that there is this concept of the coefficient of restitution that comes in, and that gives us our second piece of information for that particular impact problem, right? And once, if we already know the coefficient of restitution, which we can find by looking at various data books or data tables and so on for various different impact problems, then we can use that piece of information to find our final velocities of the two particles. Now this was of course the case for what you call it, central impact problems, where the particles were colliding head on. They were colliding along the line of impact like so. So for this problem, we saw how we can apply the conservation of momentum and the coefficient of restitution, whereas there was this other type of impact which was oblique impact. And what we did for oblique impact was that we saw how we can actually, because momentum of course is a vector quantity, so we can break up this the conservation of momentum, or look at the problem in its x and y or its different component equations, right? We can break down the vector equation into its component scalar equations. And if we do that for oblique problems, then what we see basically, let me remove that from here for now. Then what we see basically is that in oblique impact, when we analyze it along the line of impact, then we have a problem which looks extremely similar to the central impact case. So along the line of impact, what we end up having, let me point that out. So along the line of impact, we will have just so along the line of impact is, oh my yes, along the line of impact, which was, yikes, which was this direction for us, the x direction, we see that we just have the initial momentum, the final momentum of A, and the internal impulses which are acting along the line of impact. So for this direction, we can use our previous analysis, which is that we can use our two equations, one being the conservation of linear momentum, and the second being the equation for the coefficient of restitution, to help us solve and find the final velocities along this direction, that is, along the line of impact. Whereas perpendicular to it, that is along the y direction, if I look closely in this case, then we see there is no internal impulse acting along the line. Apologies. There is no internal impulse acting perpendicular to the line of impact, that is in this y direction, which means, okay, on either of the particles, if I look at them, there is no impulse acting in that direction. na external impulse, neither is there an internal impulse. So which means that by the conservation of linear momentum for each particle A and B, right, in this case A or B पे individually conservation of momentum लग सकता है, because we have no impulse at all acting on either of the particles in this y direction. So उससे क्या होता है, that means के it's just the case के y direction में कोई momentum change cause ही नहीं हो रहा, such that we just have the initial velocity perpendicular to the line of impact will be equal to the final velocity perpendicular as well to the line of impact for both the particles A and B. So that is, then we get our four equations. या फिर four equations कहना भी it's a bit of a मतलब ऐसे ही unnecessary बात है, right? Point is कि perpendicular to the line of impact the velocities do not change because momentum is just conserved without any for each particle. Whereas along the line of impact, momentum is conserved for the system of the two particles. Okay, this is a little subtle, right? So perpendicular conservation holds for each particle, whereas along the line of impact, conservation holds for the system, for the two particles taken together. Okay, so that's the things that we had discussed last time. Or also, I forgot to mention it. We did have a little bit of a discussion also on the what the coefficient of restitution means. So we discussed how there are the coefficient of restitution only lies between less than equal to, so apologies, I think I better just write it down. It lies between for real world particles less than 1 and greater than equal to 0, whereas for ideal situations it may actually be equal to 1 as well. And we discussed what these two types of extreme impacts mean, the elastic impact and the plastic impact. So elastic impact, which is when the coefficient of restitution is 1, is the case when not only is the total momentum conserved, but even the total mechanical energy is conserved in this case. Whereas for the case of the plastic impact, when E is equals to 0, then the two particles, they stick together, basically. They travel together afterwards, after the impact as well. So this case of plastic impact has the case where we have our maximum loss of mechanical energy. And in this case, only the momentum is conserved, okay? Not the mechanical energy, right? So these were some of the things that we had discussed, along with loads of, I'm sure, smaller other bits and pieces as well. So today I want to jump into doing the examples for impact. So just to apply everything that we've just been learning about. So just to clarify, do any of you have any questions from last week's lecture about impact? Yeah, all good. If I'm not getting any questions, that I'll assume.
Clear, Rama.
Clear.
Good.
Thank you, Abdullah, for letting me know. Right. Okay. So then let's jump to our example. Pens and papers and calculators out, everybody. Okay. Right. So it's a race between each of us. Okay. What's happening here? We've got a 5.5 kg ball which is ejected from the tube at A with a horizontal velocity of 2 meters per second. The coefficient of restitution at B is 0.6. मतलब ये कि it travels from here, falls down just because of gravity, and then it it collides or it strikes the ground, या फिर this inclined plane at B. That is, it has an impact here at B. So that's what we're trying to analyze. So what we want to find exactly is that the horizontal distance r, which the ball strikes on the smooth inclined plane, and the speed at which it bounces off. So मतलब इधर से जब वो bounce किया है, because there's a coefficient of restitution, there is some sort of, or if you note, it's less than 1. So there's going to be some energy loss. So we're trying to figure out, okay, with what speed does it bounce off the plane, right? Perfect. So that's what we are doing. There are actually, if you notice, there are two parts to this problem. One is just its motion going from A till B, which I think we guys can identify that is its motion from A to B is just straightforward projectile motion, right? There's only an initial force, yeah, impulse applied to it at A, और उसके बाद it just falls under the action of gravity. So it's projectile motion going from A to B. So using projectile motion analysis, we're going to be able to find out what this distance r is, and then also we're going to be able to find, okay, what is the initial velocity of A right before impact. ठीक, और फिर once we know its initial velocity before impact, then we can use our impact analysis to find its final velocity after impact. ठीक, so that's the strategy that I'm thinking of. So projectile motion first, and then we have our impact problem. Right. Okay. So let's jump right in. So I'm gonna start solving it right here. You guys please go ahead as well. Abhi, I'm gonna be quiet and do it silently while you solve it as well. Okay. Is anybody getting further along ahead than I am? I have just managed to come up with the simultaneous equations that I need to solve for my projectile motion. And I'm of course running out of space. I'll just do it right here. So solving 1 and 2. Okay, guys, has anyone managed to solve for the horizontal distance yet? The first part, to find r.
Yes, man.
So, Hamza, please pop in your. Sorry?
फर्स्ट में टाइम निकाला है
Time nikala. Okay. So, Tala, what is your time coming out to be? Please pop in your answers as you go along, because ये तो लंबा ही होता जा रहा है. जी, please, Tala.
1.0
Perfect. I am getting the same thing, 1.03. And Hamza, you've got your distance, r.
Yes, man.
तो वो
2.0568.
2.0 बिल्कुल ठीक है मेरा भी रफली 2.04 पे मैंने राउंड ऑफ कर दिया था आई एम ऑल्सो गेटिंग 2.06 होना चाहिए एक्चुअली वाई एम आई 2.06 होना चाहिए यस सो दैट इज ऑल्सो व्हाट आई एम गेटिंग बिल्कुल ठीक अच्छा आई एम जस्ट गोना वेट फॉर 1 minute फॉर एवरीबडी टू कैच अप क्योंकि इससे अगला पार्ट जो है ना फॉर द इम्पैक्ट लेट्स विल ऑल डू इट टुगेदर बेसिकली सो अब्दुल्ला जब आपका आर निकला है तो आप बताइएगा आई एम गोइंग टू यूज यू एज अ स्टैंडर्ड के व्हेन वी शुड स्टार्ट टू मूव ऑन क्लास मुझे शक है कि शायद अब्दुल्ला चले गए हैं सो आई विल समन आपका हो गया
मैम मैं अभी आया हूँ दरअसल
देखा
अभी
देखा
क्या
चोरी
सामान
पकड़ी गई नो प्रॉब्लम इट्स ओके एनीबडी
लेकर
एल्स
काम से गया था मैम ओके अब मैं करता हूँ मैम अभी करता हूँ
ओके अब्दुल्ला अभी आप रुक जाएं बेशक समन आपका हो गया
मैम आर 2.04 है
जी समन बोले
मैम अभी मैं कर रही हूँ अभी मेरा नहीं हुआ मुझे समझ नहीं आ रहा वहाँ पे
ठीक है चल डू यू वांट मी टू डिस्कस इट
मैम आप स्टार्ट करें मैं आपको कैचअप करती हूँ
Someone I'd like to wait. So Jabba, when you give me the go ahead, then I will start to discuss ke how did we get this T and this R.
मैम इस प्रोजेक्टाइल मोशन में हमारे पास 3 अननोन्स है ना?
मतलब कौन से 3?
T, R and the final velocity.
Yes, thank
X or
you.
Y direction.
I'm guessing this is Arij speaking. Yes, Arij, you are right. Because the question had just asked for R, तो इसलिए मैं R तक करके I'm pausing, even though I have already written out the velocity expressions. So once I know the time, I can find. You're right कि वो भी चीज़ unknown है जो हमें चाहिए. तो yes. Okay, someone take a pause. Everybody, please take a pause and come back. And please see here. So, basically, I hope everybody's back by now. We can all spot that this is the case for projectile motion, right? So, a projectile motion ke andar we all know that in the x direction, as I've drawn my coordinate system like right here, x and y, like so, from the starting position, origin at the starting position, then in the x direction, we have zero acceleration. That means that we have constant velocity in the x direction. और वही मैंने पहले क्या किया, मैंने a to b का projectile motion की पहले velocity का लिख लिया कि ये देखें x direction में we have constant velocity, right? So जो पहले थी वही b पे उसकी velocity होगी. So that's why the velocity, the x velocity in B at B is going to be 2 meters per second. But then in the y direction, we have a constant acceleration. ऐसा ही है ना? There is just gravity acting on it as it falls. So then we are utilizing our constant acceleration terms, in which what happens is that velocity to changes because of that constant acceleration. So velocity की is this expression कि जो भी initial position पे थी उसके अंदर से change हो रहा होता है because of that constant acceleration. So it's just VAY पे जो भी था and then minus GT because minus Y because the gravitational acceleration is acting downwards whereas my Y is in the positive direction. So that's how I've got my two expressions for the velocity. But let's just park it here. इसको इधर ही park कर लें. क्योंकि सवाल अभी हमारे पास जब मैंने ये expression लिखी ना तो मेरे पास time था. I don't know the time of this projectile motion. So I actually need to go somewhere else and look at the distances traveled या फिर the displacements under this projectile motion. अब again as before in the x direction we have no acceleration, which means we have constant velocity. So in the x direction then, idhar dekhiyega please, in the x direction I have a case of displacement under constant velocity, which I have written down the expression right here, which is ke SBX, matlab final displacement jo hogi, that is going to be the initial displacement plus the velocity times the time. So that's why I get this expression right here, ये जो मैंने ये लिखी हुई है, r is equals to 2t. Whereas in the y direction, and now move here please. In the y direction, I have a case of constant acceleration. So what I've done is I've just written down the expression for the displacement under constant acceleration right here. और उसकी value substitute करके I get this second equation which relates this horizontal distance r with t. Just notice कि जो total vertical distance travel किया जा रहा है that's in the minus direction. That's why I've got a minus here. And the total distance is 4 plus this r tangent 30. Now, solving these two simultaneous equations together, we get that the time turns out to be 1.03 and this r distance turns out to be 2.06. तो वो जो question पूछ रहा था वो तो हमने कर लिया है. Well and good. But now comes the next part which we are going to solve together, which is looking at the impact. So I hope the projectile part is now clear. Okay? something we've done. So koi error ho to please come back and see where you might be going wrong. Now for the impact part, you guys recall कि हमें impact के लिए velocities before impact पता होनी चाहिए ताकि using the information about impact we can find the velocities after impact. ठीक? So I need to know the velocity of my ball before impact at B. That's why I need to know my VBX or VBY which I've just found. VBX will be the same as as we discussed. This is going to be 2 meters per second. और VBY को मैंने constant acceleration की term की expression use करके find कर लिया है now that I know the time. So VBY turns out to be minus 10.1 meters per second. Great. So with those two pieces of information, which is कि right here, I know कि velocity of the ball का क्या components हैं. I know basically कि VBX is 2 meters per second and VBY was minus 10 meters per second, meter per second. So what does that tell me? That tells me that if I draw it as some sort of a magnitude and direction from the horizontal, then I know that ये at VB or usko, let me now say it is before impact, right? You guys all identify it as before impact. So I'm going to call it VB1. Velocity of the ball at B before impact. उसका magnitude क्या आ गया मेरे पास? Just using these two. By the way, it was minus 10 point. RH, what was it? 10.1 था ना? 3 significant तो जरूर at least रखना चाहिए.
मैम 10.088 है.
10.088, which is 10.1. That should be fine. So if I find
10.088 ma'am.
ठीक है जी, तो वो 10.1 आ गया. So if I find the magnitude of the velocity before impact, please notice VB1, then that turns out to be what? It is 10.3 meters per second. Excellent, done. Secondly, let me also find कि उसका angle क्या है? What is the angle it's making from the horizontal like so? What is this theta? जो ये पूरा यूं आ रहा है. That theta is going to be what? Tangent inverse of 10 point, oops, no. Yeah, 10.1 divided by 2. Why? Because I'm drawing out this angle. ये वो velocity आ रही है, VB1 before impact, और उसका ये angle क्या है with the horizontal. So I know that this component is 10.1 and this component is 2. So I can find what my theta is. और theta क्या आ जाता है फिर? 78.8 degrees for me. Right? So is that fine with everybody? 10.3 is the magnitude and the angle is this. Now, why am I doing all of this? Why am I finding the magnitude and the angle theta? Let's now see what happens if I move to the impact problem. Let me just draw in that same piece of information again because we're going to need it. अब आते हैं कि हमारी जो impact problem है वो तो along this plane हो रही है. And we all know कि हमें अपने line of impact को identify करना होता है. तो उसके लिए ना let me draw this out ताकि it makes my life a little bit easier. This is my plane जिस पे वो impact हो रहा है. का ये वाला angle is given 30 degrees. और फिर वो let me just look at the point of impact. मतलब ये कि वो impact जब हो रहा है. Sorry ये इधर touch करना चाहिए था, ज़ाहिर है impact हो रहा है. So you guys recall कि I had discussed with you कि वो line of impact is something that represents the normal to the surface of the contact, right? Surface of the impact. So in this case क्योंकि ये ground है पूरा, इसका मेरे लिए center of mass जो है ना basically का मतलब है कि कहीं वो बस इस surface से दूर perpendicularly है और इसका center of mass तो यहाँ है. So that is if I draw out the line of impact, that's going to be something that is just like so. This is the line of impact. And now if you recall from our जो previous discussion, that what we want to do is कि हम अपने ना impact problems के लिए x और y coordinates को along and perpendicular to the line of impact define करना चाहते हैं, which means कि how we're going to define the x and y coordinates right here. देखें, x को along the line of impact, that is in this direction, along the line of impact. फिर मेरा y क्या हो गया, मेरा y coordinate हो गया ये वाला. तो अब मेरे पास ये मेरे नए x and y coordinates आ गए हैं. The reason being because we know कि along the line of impact and perpendicular to the line of impact we have some different pieces of information. और हम coordinates को ऐसे define करना चाह रहे हैं ताकि हम easily वो उस information को represent कर सकें. Right. So अब मुझे ऐसा करने दें कि because ये this theta I had calculated to be 78.8. Now let me define कि अच्छा अगर मैं इन x और y coordinates के along इस VB1 को define करूँ फिर क्या होगा. So then what I'm doing is कि I have this angle as before, लेकिन फिर ये 30 degrees के along मेरा y है, इस direction पे मेरा y coordinate है ना. So this is my y direction and this one is going to be my x direction. So what is the angle that forms? ये 30 है, ये 78.8 है. तो इन दोनों के दरमियान में क्या एंगल हो गया फिर? 48.8 degrees. Right? So now what are my two components? Where is my pointer? Now my two components of my velocity are going to turn into this one and this one. And what are they? Let's write that down. Clearly VB1 का, ये VB1 था ये वाला और उसका मैग्नीट्यूड था 10.3. उस VB1 का 10.3 का x component, this one, the x component is going to be, देखें, minus x direction में, so that's minus 10.3 what? Sine of 48.8. ऐसा ही है. फिर the,
Yes.
thank you Saman, and then VB1 का y component क्या है? नोट कि प्लीज ये y और x मैंने नए डिफाइन किए हैं इम्पैक्ट प्रॉब्लम के लिए. सो VB1 का y component क्या है? That's going to be again वो भी minus y direction में है. So that is again minus 10.3 cos of 48.8 degrees. So we have to keep this in mind कि I have now defined my coordinates parallel to and perpendicular to my line of impact, and now I have neatly found my velocity before the impact along these new coordinate system. और why we are doing that is because जो हमारे पास सारी information है वो इसी दो directions में है, right? और वो information है क्या? अब let me write that down as well. We know कि along the line of impact, इसको ऐसे कह लेते हैं, that is हमारी x direction in this case. उसमें क्या होता है? Along the line of impact ही हमारे पास हमारा internal impulses, मतलब ये कि इन दोनों के दरमियान में कोई forces act करती हैं और वही वो normal force होगी ना. That means कि along the line of impact we have our conservation of momentum for the system, and we have our second equation which is the coefficient of restitution. Whereas perpendicular to the line, perpendicular to LOI, we only have what? Can someone tell me? Anyone? Guys?
VAY?
यस वो वी ए वाई तो मतलब सॉरी वी वी बी वाई है बाय द वे. हम बॉल को अब कि वन वेलोसिटी को एक्स और वाई में रिप्रेजेंट कर रहे हैं. नहीं, परपेंडिकुलर टू द लाइन ऑफ इम्पैक्ट क्या होता था हमारे इम्पैक्ट प्रॉब्लम के लिए? कंजर्वेशन ऑफ मोमेंटम तो है ही है, लेकिन कंजर्वेशन ऑफ मोमेंटम ऑफ द सिस्टम है या फॉर ईच, फॉर द बॉल इटसेल्फ है, फॉर ईच पार्टिकल है?
मैम फॉर ईच पार्टिकल होता है.
फॉर ईच पार्टिकल है. थैंक यू. और उसका क्या मतलब है? उसका मतलब क्या होता है? वेलोसिटीज को क्या होता है फिर?
मैम वो सेम रहती है.
थैंक यू, एग्जैक्टली राइट. वेलोसिटी अनचेंज्ड रहती है इन दिस डायरेक्शन, perpendicular to the line of impact. The velocity remains unchanged. If you guys have forgotten this, let me just show you. Yes, Irana moved so far ahead. See, remember, perpendicular to the line of impact, the velocity remains unchanged because the conservation of momentum holds for each particle. Whereas along the line of impact फिर हमारे पास पूरे सिस्टम के लिए conservation of momentum है और coefficient of restitution है. So be careful कि कौन से हमें वो डायरेक्शन के along क्या piece of information available है. So इसी वजह से I have defined my line of impact like so कि उसके along मैंने x direction define की और y direction. अब आते हैं each individual directions को consider करने के लिए. ठीक. सो आई होप के ये कुड समवन प्लीज मेक अ नोट के ये दो वेलोसिटीज हैं क्या? -10.3 साइन 48.8 और कॉस 48.8. ठीक. नाउ लेट मी डिफाइन के व्हाट वी हैव कंसिडर्ड सो फार. दिस इज आवर प्लेन और हमने अपनी एक्स डायरेक्शन को इधर डिफाइन किया है और हमारी ये बॉल होगी एट इम्पैक्ट. ठीक है जी. और हमारी वाई डायरेक्शन जो है वो इस तरह है. ठीक है जी. अब मेरे पास अगर आप देखें ना तो दो पार्टिकल्स हैं, मतलब इम्पैक्ट किन दोनों के दरमियान में हो रहा है? बॉल के दरमियान में और ग्राउंड के दरमियान में, राइट? सो प्लीज नोटेड आई एम गोइंग टू हैव वी बी वन, बट आई एम ऑल्सो गोइंग टू हैव वी ग्राउंड वन, either where my b is the velocity of the ball, okay, at b before and after impact. So ये हो गए दोनों की velocities before impact. फिर of course I'm going to also have VB2 and VG2, that is after impact of the two particles. Now let's see कि हम अपनी problem को break down कर देते हैं. Parallel to and perpendicular to the line of impact. ये हमारी line of impact थी. So along x-axis, what information do we have? As you guys recall, we know that there is the conservation of momentum for the entire system. So the first thing that we know is that, somebody help me write that down, velocity of the ball before plus the mass of the ground and velocity of the ground before. This is going to be equal to the final momentum, right? So m ball v ball after plus m ground v ground after. Lovely. The second equation that I have is the coefficient of restitution. This along x-axis, which is the LOI, the line of impact ke along. The second equation I know is the coefficient of restitution, which tells me what? V ground was the one जो पहले कर रहा है. V ground 2 minus V ball 2 divided by V ball 1 minus V ground 1. Please be careful about the orders right here. The first one is the relative velocity of on the numerator is the relative velocity of separation, whereas the denominator is the relative velocity of approach. तो ये बड़ा ध्यान से लिखना पड़ता है. अब इसको ज़रा डिस्कस करते हैं कि हम इसमें से कौन सी एक्सप्रेशन की हमारे पास इंफॉर्मेशन नोन है. पहली बात तो ये कि अगर हम इस सिस्टम को उस तरह देख रहे हो तो हमारी नज़र में एटलीस्ट द ग्राउंड इज़ स्टेशनरी बिफोर एवरीथिंग इज़ हैपनिंग, राइट. सो दिस वी ग्राउंड इज़ जस्ट बेसिकली इट्स स्टेशनरी अप्रॉक्सीमेटली. लेकिन इवन आफ्टर आवर कोलिजन फिर आपको लगता है कि द ग्राउंड इज़ गोइंग टू बी मूविंग अ लॉट, कोई बहुत ही ज़्यादा जी उसकी मैसिव किस्म की वेलोसिटी हो जानी है. नहीं, ग्राउंड तो उधर ही फिक्स्ड ही रहता है. सो टू स्पीक द ग्राउंड रिमेन्स स्टेशनरी इवन आफ्टरवर्ड्स. So this Vg1 before impact is 0 and the Vg2 after impact is also approximately negligible. Is that right or not? Would you all agree with that?
Yes, ma'am.
So for my equation right here, these two are going to disappear. And all I'm left with actually is just the coefficient of restitution with the velocity of the ball afterwards and the velocity of the ball before. What were the velocity of the balls? VB1 along the x direction was minus 10 point. I did ask you guys कि कोई मुझे याद करा दीजिएगा. Minus 10.3 sine of 48.8 था. Thank you. And VB1 y was minus 10.3 cos 48.8 degrees. ठीक है जी. So अब along the x direction ही हम कर रहे हैं. I forgot to write कि this is all the x. Right? So this is VB2x, this is VB1x. तो अब इस पे आते हैं कि ये तो कोएफिशिएंट ऑफ रेस्टिट्यूशन की ही जो इक्वेशन है मेरे पास, उसी के अंदर मेरा ग्राउंड की वेलोसिटी ज़ीरो हो गई हैं. तो आई कैन डायरेक्टली जस्ट यूज़ माई कोएफिशिएंट ऑफ रेस्टिट्यूशन टू फाइंड कि मेरी फाइनल वेलोसिटी क्या होगी बॉल की आफ्टर कोलिजन, बिकॉज आई हैव ऑल द इंफॉर्मेशन आई नीड राइट फ्रॉम हियर. So substituting all the values that we know, let me change the color. The blue just somehow for me is a little difficult to read. So E is, we know, is 0.6. So 0.6, that's going to be equals to minus VB2, velocity of the ball after impact in the x direction, where x is along the line of impact. And that is divided by VB1x, जो कि VB1x we know ये रही हमारी, हमने पहले ही लिख ली थी. So that's minus 10.3 sine of 48.8. और इसको अब हम जब सब्सटीट्यूट करें डायरेक्टली तो मेरे पास मेरा VB2 in the x direction आ गया है. That is 10.3. What do we get?
4.64, 4.62.
चलें, कोई राउंडिंग एरर्स हैं, बट येस आई एम ऑल्सो गेटिंग एग्जैक्टली द सेम थिंग. प्लीज़ नोटिस कि अब द वेलोसिटी VB2x जो है दैट इज़ टर्निंग आउट टू बी पॉजिटिव. मतलब ये कि अब वो इस प्लस x डायरेक्शन में एक्ट करेगी, विच मेक सेंस. इम्पैक्ट से पहले वो इस माइनस x डायरेक्शन में आ रही है और अब उसने ऊपर की तरफ जाना है relative to this x direction. So perfect, we've got our VB2x. Please note कि in this case जब हम कोई, अभी मैं बहुत important बात करने लगी हूँ इसलिए everybody should pay attention. Yes, बिलाल, ये बिलाल ने वही बात, बिलाल आप इधर कह रहे हैं ना, yes, मैं इसी चीज़ पे आने लगी. Excellent बिलाल, I exactly wanted to discuss this. बिलाल कह रहे हैं कि अभी जो ये हमने along x axis हम सब कुछ अप्लाई कर रहे हैं, इसके अंदर ये कुछ अजीब सा कॉन्ट्रडिक्शन नहीं आ रहा कि हम कह रहे हैं जी वेलोसिटी ऑफ द ग्राउंड जो है वो ज़ीरो है, तो फिर इधर मोमेंटम में क्या होगा? मोमेंटम साहब में इसका तो मतलब ये हुआ कि मोमेंटम अनचेंज्ड है इवन बॉल का. इस पे आप डिस्कस करते हैं. बिलाल प्लीज़ नोटिस कि आई हैड सेड कि इनिशियली इफ़ यू जस्ट टेक द ग्राउंड टू बी एट रेस्ट, But then after collision, I'm not saying कि ground rest पे ही है. I'm saying कि उसकी velocity is so small कि I can consider it to be negligible. And why is the velocity of the ground so small or it is negligible is exactly because conservation of momentum के हिसाब से, now please look here, ये equation 1 जो थी, उसके हिसाब से the total momentum of the entire system has to be conserved. Now अगर if I have taken the initial momentum to be 0 of the ground, so how does the conservation of momentum still hold true? Is because after collision, the ground actually does move, but it moves with such a small velocity because because the mass of the ground, this thing is massive. This is the mass of the earth, right? So इसी वजह से because of the conservation of momentum, which is basically telling us कि जो भी ये momentum change हुआ है ना ball का, that has to be balanced by the equal and opposite sort of change in the momentum of our ground ताकि total momentum conserve हो throughout. That is exactly why I am able to say कि ground की velocity after impact is just going to be negligible because उसका mass is so large ताकि जब वो मल्टीप्लाई होंगे ना तो फिर ये कंजर्वेशन ऑफ मोमेंटम बिल्कुल सही तरह होल्ड ट्रू करेगा. मतलब ये कि इसमें कोई कॉन्ट्रडिक्शन नहीं होगी. ओनली दैट what we are easily able to sort of assume or state is that this velocity of the ground after impact is going to be very very small because the mass of the ground is so large. और इसी because the velocity is going to be so small, that's why I've just assumed कि this is approximately equal to 0 इधर the final velocity
मैम
of the ground. हाँ जी.
मैम तो ये हम ये बोल रहे हैं कि लाइन ऑफ इम्पैक्ट के अलोंग जो है वो हम लोग इक्वेशन ऑफ रेस्टिट्यूशन यूज करेंगे और कंजर्वेशन ऑफ मोमेंटम यूज नहीं करेंगे और उसके परपेंडिकुलर सिर्फ कंजर्वेशन ऑफ मोमेंटम यूज करेंगे.
यही कह रहे हैं लेकिन उसका एक रीज़न है. आप ये बड़े केयरफुली देख लें कि इट्स ओनली बिकॉज द वाई we are not needing to use the conservation of momentum right here along the line of axis is because conservation hold तो कर रहा है बिल्कुल सिस्टम के लिए, लेकिन हमें यूज़ करने की ज़रूरत नहीं पड़ी बिकॉज हमने velocity of the ground को assume कर दिया कि it's just going to be negligible even after impact. ठीक. So you're right to state what you just said, but I just want to clarify to you कि it's not कि वो hold नहीं करता, it's only कि for our case we then don't need to use it क्योंकि हमें coefficient of restitution वाली ही equation के अंदर हमने उसकी velocity को assume कर लिया है कि वो क्या होगी final velocity, which is why it makes our life easier कि हम सीधा एक ही equation को use करके अपनी final velocity of the ball find कर लेते हैं. ठीक. सो ये बात प्लीज़ सब लोग नोटिस कर लें कि कंजर्वेशन ऑफ मोमेंटम जैसा हैज एज बिलाल हैज सेड कि देयर इज़ नो कॉन्ट्रडिक्शन. ओके, इट्स जस्ट दैट द मास ऑफ द ग्राउंड दैट इज़ द मास ऑफ द अर्थ इज़ सो लार्ज कि जो उसकी चेंज इन मोमेंटम होता है उसकी वजह से इट जस्ट हैज़ अ वेरी नेग्लिजिबल वेलोसिटी दैट इट एक्वायर्स बिकॉज ऑफ इम्पैक्ट, क्योंकि वो मास उसका इतना लार्ज है तो इसलिए उसकी वेलोसिटी बहुत ही छोटी होती है जो इम्पैक्ट के बाद होती है. एंड दैट्स व्हाई वी डोंट सी इट, वी डोंट नोटिस इट व्हेन वी आर जंपिंग अप एंड डाउन ऑन द अर्थ एंड सो ऑन. ठीक है जी. सो आई होप दैट इज़ क्लियर टू एवरीबडी. और एक पार्ट सिर्फ रह गया है विच इज़ परपेंडिकुलर टू द line of impact, which is along our y-axis. So we still have to do our perpendicular to the y-axis. So I have to remove it each time. So perpendicular to LOI, that is our y-axis की direction. In that direction, we just know that the conservation of momentum holds true just for the ball. That means that the velocity of the ball even after impact is just equal to the velocity of the ball before impact in the y direction. It is very important, this y direction. ठीक, so that is why it just is जो पहले थी, that was ये जो हमारे ये x और y directions हमने define किए थे, it just was something minus 10.3 cos of 48.8, something like that. So उस direction में it just stays the same. ठीक, so what is that exactly? It turns out to be 10.3 cos of 48.8, so that's minus 6.78 meters per second. And now I can find my sort of speed that is being asked, speed at which it bounces off. The speed is going to be the magnitude of these two. So the magnitude of the velocity, and that is पहला वाला था 4.24 था, I think, squared plus 6.78 squared का square root, उसके x और y components आ गए. So that is roughly 8.0 I'm getting meters per second is the final velocity. और वही आप देखें कि उसने शुरू कहाँ से किया था, उसने शुरू किया था VB1 was minus, या फिर उसका मैग्नीट्यूड खाली लिख लेती हूँ, it was just 10.3 था आई थिंक, या 10.3 मीटर पर सेकेंड का उसका मैग्नीट्यूड था, और आफ्टर इम्पैक्ट उसका मैग्नीट्यूड जो है 8 मीटर्स पर सेकेंड आ रहा है. So उसकी speed before impact was 10.3 and its speed after impact is turning out to be 8 meters per second. Right, guys? So let me just check if our solution is correct in our yes, but I really want to emphasize this fact. It is 8.21 aa raha hai, so 4.64 tha. I'm sorry, I had made a mistake in my assumption के 4.24 मैंने गलती से ले लिया था, it was 4.64. Right, so this is extremely important to note कि when I'm taking my x-axis and y-axis, where x-axis is along the line of impact and y-axis is perpendicular to the line of impact, then उन दोनों को अलग अलग मैं analyze करूँ, noting के along the line of impact, that is along my x direction, I'm going to have both the coefficient of restitution and my conservation of momentum for the system holding true. लेकिन the only important thing is कि ground की velocity को हम assume कर लेते हैं कि even after impact it is just negligible, and because of that we are able to just directly use the coefficient of restitution. ठीक है? Whereas momentum जो है हमें consider करना नहीं पड़ता, even though the conservation of momentum still holds true. ठीक? Whereas for the y direction that is perpendicular to the line of impact, we just have a very straightforward situation where the velocity of the ball remains unchanged before and after impact. ठीक? So this is a complicated thing. Do take a look at it again in more detail yourself, or do ask me if you have any questions. Right, so ये वाली ज़्यादा मुश्किल थी, that's why it's taken us so long. The second problem is very short and very easy. That's why we're just going to solve. अगर if you allow me to just go a few minutes over time, then we can just solve it right here, right now, when everything is fresh in our memory. So in this case, we have clearly a problem of central impact, right? If you notice, just इसी का line of impact when they come in contact is going to be along this direction, और उनकी initial velocities भी इसी direction में. So this is central impact problem. And now what's happening? So we have a 2 kg block A, which is released from rest, and it falls a distance of this 0.5 meters. और गिरेगा जब, as it falls this distance, then its potential energy is being converted into its kinetic energy, such that it will have some initial velocity of impact. And then it strikes this plate of 3 kg mass. Now we are saying the coefficient of restitution between A and B is 0.6 and the spring stiffness is something along right here. So what we want to do is we want to find the velocity of block A just after collision. ठीक है जी. So पहले तो clearly impact से पहले की हमें velocity चाहिए ताकि फिर हम impact को analyze करके उसकी after collision find कर सकें. So for the initial part we can just use either projectile motion, मतलब ये कि falling under gravity, या फिर just use an energy method, that is the conservation of, because there is no non-conservative force acting on it, we can just use the conservation of mechanical energy for A to find its initial velocity. ठीक, so let's jump right in and do this problem. Okay, so पहले तो
conservation momentum common velocity लेकर
किस चीज़ का, सॉरी?
conservation momentum and common velocity.
देखें, अभी पहला पार्ट ये है ना कि जब इम्पैक्ट होने से पहले की मुझे वेलोसिटी फाइंड करनी है, कि जब वो ए गिरेगा इधर, ठीक? सो इन ऑर्डर टू फाइंड एज इनिशियल वेलोसिटी, दैट इज VA1 फाइंड करने के लिए मुझे पहले तो उसका ये जो फॉल है वो दिखना है ना, और उस फॉल के दौरान उसके ऊपर उसका वेट एक्ट कर रहा है, दैट इज देयर इज एन एक्सटर्नल फोर्स एक्टिंग ऑन इट, which means that the conservation of momentum does not hold for A as it falls to the ground, to the spring. ठीक? So initially we just have the conservation of mechanical energy. Because there are no non-conservative forces acting, या फिर only conservative forces are acting. So that's why I then have T1 plus V1 is equals to T2 plus V2. Let me define the datum from here. ये जो H है, this is my datum. So then I have, initially it starts from rest. So the initial kinetic energy is 0. It has also datum मैंने ऊपर ही define किया, so it has a 0 potential energy. और अब T2 find करने के लिए जो मैं अभी, ये मेरा 1 point है और ये मेरा 2 point है as it falls, not impact. अभी impact पे नहीं आए हम, अभी सिर्फ वो fall की बात हो रही है. So fall के ऊपर its final velocity is going to be VA squared is going to be equal to but just minus mg or h is 0.5 is equals to 0. So I can find then कि उसकी velocity क्या थी before impact. Turns out to be 3.13 meters per second. Right?
Yes, ma'am.
So
Yes.
perfect. So अब हम आते हैं अपनी impact problem के ऊपर. Again, what is the line of impact? वही वो मैंने आपको बताया था, वो normal की तरह है. So ये रहा मेरा line of impact. मैंने क्या करना है अपना, उसी ये सेंट्रल ही एक्सिस है, खाली इसी डायरेक्शन को एनालाइज करना है खाली. ठीक, सेंट्रल इम्पैक्ट प्रॉब्लम. Now let's come to this. What as always, what are the pieces of information that we need? We tend to know the velocity of the, ये मेरा A है और ये मेरा B है, जो ये वाली प्लेट है. So we tend to know कि initial velocity क्या थी दोनों की before impact. And what we want to find is what is the velocity of the two particles after impact. So इस केस में let's see what do we know. We know कि ये जो B था, B भी rest पे ही था ना, I think given नहीं है, but I think we're just gonna assume कि वो spring जो है वो equilibrium पे है और B जो है easily rest पे बैठा हुआ है. So this is going to be equal to 0. Whereas VA1 हमने अभी find किया है, and it was, अभी जो find किया था हमने कि वो impact करने से पहले उसकी velocity क्या होती है, it is 3.13 meters per second but acting downwards. So अब I think what would be good for me is कि I should start defining a positive direction. So let me consider कि मैं इसी को ना, I know कि वो x और y करना होता है, इसलिए I'm just going to consider this to be the upwards positive direction और इसको x ही define कर देती हूँ. Okay, so it was acting downwards, so this is a minus 3.13 velocity. Now, what were our two equations? The first one was the conservation of momentum. चलें जी, अब वो लिखना शुरू करें. So MAVA1 plus sorry, MBVB1 is going to be equal to MAVA2 plus MBVB2. What do we know? Velocity of B was 0 initially. तो एक तो हमें ये इक्वेशन आ रही है. अब इसमें सिर्फ स्ट्रेट फॉरवर्ड सब्सटीट्यूट करनी है हमने चीज़ें, तो वो करते हैं ज़रा. 2 times minus 3.13. Please note, upwards is positive for velocities. So 2 times minus 3.13 is going to be equal to, again, 2 times, but VA 2. I don't know what its final velocity is. And this plus MB was 3 kg, so 3 VB2. दो unknowns आ गए. ये मेरी पहली equation हो गई. Conservation of momentum for the system along the line of impact. ठीक? Now, what's my next equation? I know my coefficient of restitution. और अब मुझे ये somebody will tell me coefficient of restitution के numerator में क्या होता है?
Final velocity.
Final velocity किस चीज़ की, कब, कौन?
VB2
System में.
of separation. ठीक है, final velocity of separation. separation के अंदर impact होने से B acquire करेगा, इसलिए पहले ये आएगा VB2 minus VA2. और in the denominator is the relative velocity of approach. A आ रहा है B की तरफ, इसलिए A की velocity is going to be first VA1 minus VB1. ठीक? So substituting these guys in here, only this one is 0. So the rest is E is 0.6 multiplied by VA1, which is minus 3.13, is going to be equals to VB2 minus VA2. And now this is my second equation right here. And I have two simultaneous equations and two unknowns, so I can solve this. So let's do it very quickly if we can. मैं इधर थोड़ा कहीं रफ ही तरीके से करने लगी हूँ, if you guys don't mind. So I'm gonna use this part.
मैम हो गया सॉल्व, डायरेक्ट कैलकुलेटर से आप वैल्यूज ले लो.
हाँ जी, क्या आई है जी, बताएं. VA2 turns out to be
minus 0.105.
105.
Yeah.
Okay, I might have made a mistake. I'm getting minus 0.125. Okay.
नहीं, वो आपकी का सही है, मैंने वैल्यूज गलत डाल दी, सॉरी.
No problem. Could someone else confirm? I'm getting this to be my VA2.
Yes, ma'am, यही आया.
Thank you so much. तो luckily actually मैंने वैसे सोचा, सॉरी, मैंने सोचा नहीं था और वो वही आ गया. I had मतलब ये कि I hadn't actually intentionally planned के velocity of A मैं निकाल लूँ. Whereas the way I've solved these two simultaneous equations, it's directly, it's the velocity of A after impact that I'm finding. So that's very useful. Whereas अगर हमने पहले b निकाल ली होती VB2 तो फिर just substitute करके we could have found it. So yes, it turns out कि VA2 अभी भी नेगेटिव आ रही है. मतलब ये कि this is very interesting. एक काम करते हैं ज़रा VB2 भी मुझे बता दें if you guys have found it कि इन दोनों की velocities after impact क्या आती है. VB2 क्या आती है?
2
-2
-2
माइनस या
-2
प्लस?
minus
माइनस
प्लस तो नहीं सकती मैम.
-2 meters per second. वही that's what I was wondering. प्लस तो नहीं हो सकती क्योंकि physically if you think about it, pretty interesting. Now because there is they're both essentially जाहिर है मतलब ज़रूरी नहीं है वैसे लेकिन just determined by the coefficient of restitution कि क्या होगा. इस केस में क्या हो रहा है कि even though initially वो लोग A उसके ऊपर गिर रहा है B 0 था तो they were going downwards, right? A was falling downwards and then after impact again A की भी velocity negative है B की भी negative है. मतलब ये कि ये दोनों ही फिर भी नीचे की तरफ ही जाते रहते हैं. कभी कभी as you guys have noticed जैसे कि was the case previously that the ground was at rest और ball bounce कर रही थी. So ball ने नीचे आके फिर it sort of went in the other direction, the velocity, whereas here they both after the impact they both travel downwards. दोनों की velocity negative आ जाती है. Okay, so that was just it. Or yes, one more interesting piece of information. Okay, please notice कि for our impact जब immediately हो रहा है ना, that's between A and B. तो जिस तरह हम पहले we had discussed के what are impulsive forces and non-impulsive forces and so on. So उसी तरह just for the case of the impact, spring force जो है ये जो नीचे लगी हुई है उसके that does not even come into play. वो तो जब इम्पैक्ट हो के ये बी नीचे की तरफ मूव करना शुरू करेगा तो फिर वो टाइम ड्यूरेशन इज़ लार्ज कि देन द स्प्रिंग फोर्स नीड्स टू बी कंसिडर्ड फॉर दैट मोशन बट इनिशियली जस्ट फॉर द मोमेंट ऑफ इम्पैक्ट that spring force is not going to cause a large enough impact for us to large enough impulse for us to include it. वो impact का time duration is so small कि we're just वो बस before impact और after impact हो गया है बस. So इसीलिए ये spring stiffness का कोई काम ही नहीं है. It's just not required for the instance of impact. Right guys, okay, so this was the two examples that I wanted to go over for impact. It's there's just quite a bit of arithmetic in it जिसमें थोड़ा सा ध्यान से रहना पड़ता है कि किसके अंदर क्या चीज़ substitute कर रहे हैं कि जी velocity of A before impact, velocity of A after impact and so on and so forth. So just be careful, have your presence of mind is what's required for these problems. Other than that there isn't actually anything conceptually difficult. The one thing that was there we've already discussed ke why don't we use the for the cases where we've got impact against the ground, that is when we have things bouncing off the ground, then फिर हमें even along the line of impact momentum conservation of momentum क्यों नहीं use करना पड़ता. That's just because हम velocity of the ground को negligible consider करके we can directly just jump to using the coefficient of restitution. Okay, so just keep that in mind. And yes, so I'm now available for any questions that you guys might have. Sorry for going a little bit over time.